A feedback echo effect is created by using parallel processing, similar to the feed-forward echo, except in this case, we're going to take the output of our system and feed it backwards to the input of our system. This will make it possible to achieve multiple repetitions of our input signal by just using a single time delay block. Typically, we want these repetitions to decay in amplitude over time. Therefore, we're going to change the gain on our parallel delayed path by an amount less than 1 or 0 dB. Otherwise, these repetitions could go on forever without decaying in amplitude. Let's go ahead and open up MATLAB and look at how we can create the feedback echo. Here in MATLAB, let's look at how we can implement our own feedback echo. The idea here is we're going to take our output and feed it back towards our input through a delay line. I'm going to demonstrate two different methods to create this effect. I've already started this script where I'm going to import in a sound file. I'm going to make use of some of the code we created previously. Before going any further, let's say as an example what we're trying to create is the feedback echo with a tempo synchronized delay time. So what I'm going to do is come back over here in our script that we created. We know that our tempo is in BPM. We have this whole conversion in place. So I'm going to grab this, recalculate our samples of delay. Copy this over. So we've now been able to determine our delay time. And let's say we're interested in making it at 8th note, which means we're going to multiply here this note duration of 0.5. So now I'll have 8th note feedback delay. Let's also say that we know that the repetitions, they're going to go on for an extended period of time after our signal. With feedback, we can control how long these echoes are going to go for. So let's even add some zeros on to the beginning of our signal so that we'll have this nice long tail afterwards. So I'm going to take our variable x, our input variable here, and I'm going to concatenate it with some zeros. How about zeros 2 times the length of our signal x? Here we go. Great. So now we have our signal and then extra space that we can have these repetitions occurring. All right, let's go back and look at our feed-forward echo. Here, there's a couple different methods that I demonstrated. Let me grab this approach with the array indexing, and let's look at what we can do to modify this to create feedback instead of a feed-forward approach. So to begin with, I'll uncomment some of these lines. Great. The first thing we do in this approach is we initialize our output. We're going to have zeros that's based on this length of x. We're going to overwrite that by going through this loop. We also have this gain. We're going to say that our gain here is for our feedback path. In many ways, the gain is going to determine how long these repetitions are going to persist in our system. So here what we're going to do is take our output and feed it back towards our input. So what will happen is we're going to make use of our output in the past. So initially, it's true, we do want to have our input here combined with 0 because we don't have anything yet in our output that we're going to delay. Then when we get to this else condition, we have our output. Instead of adding our input signal here plus our input signal here, let's do something where we're going to use our output signal in the past. So this is a way of creating feedback where our output at the current time sample depends on our output at a previous time sample that we're adding in here. So I'm scaling that amount here by 0.5 or minus 6 dB each time. So we should be able to listen to our output here, the current sampling rate, and hear the repetitions. So now we've implemented one method. You can hear that we're not just having a single repetition like we had before with the feedback echo. By taking our output and routing it back towards our input that we add together here, what that does is it creates a repetition, and then that repetition gets fed back through the system again. And then those repetitions get fed back through again. So we can create this long tail of delays or echoes. Let's look at another method then. So I'm going to comment out this approach here. And we'll go back. We use this other approach with the delay buffer. Look at how we need to modify this one to create the effect. So we're going to initialize this block that keeps track of our samples we want to delay. And each time through, we're going to shift things back through our buffer that we're going to use. We're going to initialize our output and have our feedback gain. Well, this time, what we're going to modify is what signal we put into our buffer. This is, you can think of it as the delay block. Instead of putting our input into the delay block, let's put our output into the delay block. And then we're just going to shift things down each time through. This output signal keeps moving on each index until it gets to the end. And then we use that index at the end here to create our output signal. So I'll run this script. We can hear that it creates a very similar kind of effect. Now we've created two different approaches to implementing the feedback echo. One based on array indexing and one based on the delay buffer.